There's a machine on some dairy farms that costs more than most people's houses, runs itself around the clock, and answers to nobody except the cows who decide when it gets used. This machine is a robotic milking system, and by the time this video ends, you will understand exactly how it works, what it actually measures, why it costs as much as it does, and why the same technology that transforms one farm barely helps another. Start with the strangest part. For most of the last century, dairy cows were brought into a milking parlor on a fixed schedule set by a person, usually twice a day, every day with no days off, because a cow's udder does not care what day of the week it is. That twice-a-day rhythm has shaped the entire labor structure of dairy farming for generations, and it is exactly what a robotic system throws out. A robotic system runs on what is called voluntary milking. The cow decides when she wants to be milked. She simply walks to the robot on her own, any time of day or night, and the machine identifies her the instant she steps inside, using a sensor built into an electronic collar around her neck. That collar is not just an identification tag. It constantly tracks her location, her activity level, and exactly how long it has been since her last visit. And it uses all of that to decide whether to let her in for milking or send her back out to graze. This might sound like brand new technology, but the idea is older than a lot of the farmers using it today. The first robotic milking system was installed on a commercial farm in the Netherlands back in 1992 as an experiment to see whether machines could safely handle a job that had always required a human hand. It worked well enough that by 1997, the Swedish company DeLaval had turned the idea into an actual commercial product, sold under the name Voluntary Milking System. Adoption started slowly. The technology did not reach the United States until the year 2000 and did not arrive in a dairy-heavy state like Michigan until 2009. But once it took hold, it spread fast. By 2010, close to 10,000 farms worldwide had installed some version of the system, more than 2,000 of them in the Netherlands alone, with roughly 1,000 each in Denmark, Norway, and Sweden. By 2022, that number had grown to an estimated 35,000 units in operation across the globe. In other words, this is not an experimental gadget. It is a 30-year-old technology that only recently became common enough for an average farm to actually consider buying one. Once a cow is identified and positioned, robotic arms locate and attach the milking cups automatically, guided by lasers or cameras, without a single person touching her, cleaning and stimulating each teat first the same way a human milker would before attaching the cups by hand. From that point, the machine is doing far more than just extracting milk. Sensors measure the milk flow rate in real time, cup by cup, quarter by quarter of the udder, because not all 4 quarters produce equally. Other sensors analyze the milk's composition on the spot, checking things like fat content and protein levels every single time she is milked, not just when a technician happens to run a test. The system is also constantly screening for early signs of mastitis, a painful udder infection that is one of the single most expensive health problems in the entire dairy industry, by watching for changes in the milk's electrical conductivity or an unusual drop in yield from just 1/4 of the udder. When it spots something, it flags that specific cow for the farmer to check, often days before a human would notice anything wrong just by looking at her. But here is a complication that most marketing for these machines will not tell you. Mastitis prevention through robotic milking is not a clean win. Because cows are milked more often, there is less time for bacteria to build up inside the udder between visits, which helps. But that same frequency means the teat canal, the small opening bacteria actually used to get in, is physically opened more often too, which can raise the risk of infection in the first place. At least one study tracking 20 farms after they switched to robotic milking actually found an increase in antibiotic treatments for mastitis, not a decrease. The sensors are excellent at catching problems early. They do not necessarily reduce how often those problems happen. None of this comes cheap. A single robotic milking unit costs between $150,000 and $200,000 just for the machine itself, and the 3 biggest manufacturers price out close to that same range. A Lely astronaut runs about $185,000 to $200,000. A DeLaval VMS system runs about $175,000 to $195,000. A GEA dairy robot runs about $165,000 to $190,000. And the sticker price on the machine is only the starting point. Once you add installation, barn modifications, and the supporting infrastructure it needs to run, the real total lands somewhere between $200,000 and $250,000 per robot. That is not a one-time cost either. Farmers budget another $9,000 to $15,000 per robot every single year just for maintenance and repairs. Because these machines are running dozens of times a day, every day of the year, with no scheduled downtime built into a dairy cow's biology. Each unit is also designed to handle somewhere between 50 and 70 cows, no more. So a farm with 300 cows is not buying one robot, it is buying 4 or 5 of them. which means the $1 million before a single extra drop of milk is sold. To understand what the robot is replacing, it helps to know what a cow and a human milker actually do without one. An average dairy cow in the United States produces somewhere around 65 pounds of milk a day, which works out to roughly 7.5 gallons, or about 29 liters, every single day of her productive life. A high-producing Holstein can put out more than 80 pounds a day at her peak, and up to 25,000 pounds across a full year. Multiply that by a herd of a few hundred cows, and you are talking about an enormous, continuous volume that has to be extracted, tested, and cooled correctly every day without fail, since milk cannot simply wait until tomorrow. Before robots, most mid-sized farms handled that volume in what is called a herringbone parlor, where cows line up at an angle so a person standing in a pit below can reach several udders without moving very far. A skilled crew working a herringbone or parallel parlor can process somewhere between 40 and more than 80 cows per person, per hour, depending on the layout and what other tasks they are doing at the same time. That is genuinely efficient. It is also relentless twice a day, every day, including holidays, snowstorms, and 3 in the morning, which is precisely the part of the job a robot does not mind at all. The obvious explanation for why a farm would make this investment is labor. And it is true that robotic systems cut the direct time spent on milking by 70 to 75%, both paid and unpaid, which on a several hundred cow herd can mean freeing up the equivalent of multiple full-time positions that used to be tied to the parlor twice a day, every day. But that is not actually the biggest driver of the payoff, and this is the part most people get wrong. Because cows are milked whenever they choose instead of on a fixed schedule, they end up visiting the robot 3 or more times a day on average, compared to about 2.5 times a day in a conventional parlor. That difference matters biologically. A cow's udder works on a demand system, similar to how milk supply responds to how often a baby feeds. More frequent removal of milk signals the body to produce more of it. So more frequent milking genuinely increases how much milk each cow produces, typically boosting total yield by 5 to 17%, without changing her diet or her genetics at all. Combine that yield increase with the early disease detection from the sensors catching problems before they become expensive, and farms running robotic systems, or at least 2 or more precision technologies together, see about 13% higher net returns on average. The robot is not just replacing a person's hands on the udder. It is replacing a rigid, twice-a-day human schedule with something closer to continuous, data-driven herd management, running every hour the cow is willing to show up. Here is the constraint that determines whether any of this actually pays off, and it has nothing to do with how advanced the sensors are. Adoption has grown to an estimated 35,000 automatic milking systems worldwide, but it is heavily concentrated on mid-sized operations, generally farms with somewhere between 120 and 400 cows. As of a few years ago, about 13% of dairy farms with 150 to 499 head had already adopted robotic milking. That concentration is not a coincidence. A farm in that range has enough cows to keep each expensive robot busy nearly around the clock, which is exactly what makes the economics work, since an idle robot is just as expensive as a busy one. Farms with fewer than 50 cows tell a completely different story. Many of them are already running on unpaid family labor rather than paid employees, so there is no real cash labor cost for the robot to replace, and the massive upfront investment simply cannot be justified by the math, no matter how impressive the technology is. Meanwhile, the very largest dairy operations, the ones running well past 400 cows, often stick with large rotary parlors instead. Because at that scale, a human-run rotary system can still process cows faster per hour than stacking up enough individual robots to match it. The exact same machine that transforms a mid-sized farm can be close to worthless financially on a small one and unnecessary on a giant one. The technology is not standing still either. The fastest growing addition to these systems right now is an eye-powered camera vision, layered on top of the existing sensors, so the robot can watch each cow's body condition and behavior over time, not just measure her milk. Instead of a farmer scrolling through raw numbers, newer systems are moving toward plain language dashboards, where the software simply tells the farmer in a sentence which cows need attention today and why, rather than handing over a spreadsheet and expecting a human to spot the pattern. That shift matters because the actual bottleneck on many robotic farms was never the milking itself. It was making sense of the flood of data the robots generate every single day from thousands of individual visits. As that software gets better at doing the interpreting on its own, the case for adopting robots may eventually extend further down towards smaller herds too. But for now, the constraint is still the same one it has always been. A machine this expensive only makes financial sense when there are enough cows to keep it working, every single hour, on a schedule the cows themselves are writing. So the next time you picture a farm robot, picture this instead. A $250,000 machine descended from a 30-year-old Dutch experiment, that a cow walks up to entirely on her own schedule, that reads her collar, tests her milk in real time, and quietly decides whether she needs a vet days before anyone would have noticed. Its entire value depends on a number most people never think about: exactly how many cows are sharing it, which means the most important spec on the world's most advanced milking machine was never really about the machine at all. It was always about the herd standing around it.